Hello, everyone. Hello, thank you for coming. Thank you for coming to ArgoCon. I'm going to talk for the next around 20 minutes, and I'm going to talk about how we train and ensure reliability of machine learning model at Wolt, and how we use ArgoCD, Flight, and Argo Workflow for that. Quick intro on my side. Well, no one came here for me, but still. I'm Stephen. I'm a machine learning engineer. I'm also a YAML engineer, given that I use Argo a lot. That's basically what I do all day long. In a previous life, I was a data scientist. I'm the founding member of the ML platform team, also, if you want. Founding member of the Berlin MLOps community. So if you're Berlin-based and you want to learn about MLOps, you can come to our meetups, conferences, everything. But that's all about me. Second thing, I work for Wolt. I don't work for Bolt, and I don't work for HashiCorp Wolt. So because every time people are like, oh, who are you? And yeah, so we're Wolt, depending on the country you're in. And given that we're not in Amsterdam, given that we're not in the Netherlands, I'm just going to give you a quick intro, and then we go to the technical stuff. So yeah, Wolt was created in Helsinki in 2016. We started as a food delivery company in Finland, and now we deliver basically everything you can think of. So going from food delivery to Christmas trees and to everything in the middle. We are in 23 countries now, going from Norway to Japan, going also through the stands and a lot of countries in the middle. We have a lot of users, a lot of partners, a lot of core partners. Those are just random stats. We don't really care about them. What we care about is machine learning. And we have different use cases for ML at Wolt. So I'm just going to explain the different use cases, and then we can start the talk. So the first one is supply and demand forecasting. And that's what we do when we try to predict how many people are going to order next week. Do we need courier partners next week? Do we need to buy more things for our supermarkets as well, because we also have our own supermarkets. So let's say it's a public holiday next week, maybe people will buy specific things. So that's what we're trying to forecast. We do that on a weekly basis, and it runs pretty good. Then we have recommender systems. Well, I assume a lot of people know about it. It's you buy the same dishes. We're going to try to recommend you different dishes that you might like. But also, let's think you move to a new city. You need to furnish your apartment. You can buy a lot of things on Wolt, and then we'll be like, oh yeah, you bought a lamp, you bought a chair, maybe you want to buy a desk or something, we're trying to do that. We're not trying to do the Amazon way where you buy a lamp and we'll be like, yeah, maybe you want 1,000 lamps. So we're trying to recommend you new things. Then the other one is logistic optimization. That's, I think, one of the most important one we have is, okay, you make an order on Wolt, you order a dish. We're going to predict how long it's going to take to prepare the dish, and then how long it's going to take for us to deliver the food or the object that you bought. And that depends on traffic. That one is full real time, so it's really important. And it's the one usually people complain about, because they're like, oh yeah, I ordered something, it's supposed to take 25 minutes, I've been waiting for 35, what's up? Then fraud detection, keep the bad people out. And the last one is support prioritization. So you order something, and then you're unhappy about it. It's delayed, there's a problem, we delivered the wrong object. That's, we try to prioritize by order of importance. So let's say you have a dish that is late, that one is pretty important, and other problems can maybe wait a day or two. So that's it. We have different use cases. Different use cases mean different needs. Our data scientists, they need data access. So we want them to have access to production data in a simple and yet safe way. So you don't want them to have access to the whole production database. You just want them to have access to specific tables. We make that, I would say, fairly easy for them. Then infra access as well. A lot of data scientists will need GPUs now, especially even now. So if they need GPUs, then they can request them themselves. They can make PRs. Then I'll talk about it later, but Argo will pick it up for you. And so they don't even have to apply anything themselves. If you need a lot of RAM, a lot of CPUs, it's the same. One other thing as well that we want is to make deployments of models quick, reliable, and easy. Because you might have the best model in your laptop. If it's not deployed, then it's useless. So we really want to make that easy for people, and we really want to increase the velocity of our data scientists. The last thing we want is standardized monitoring. We want to track data quality. you don't want to train a model if your data quality is not good, if you have a problem with the data, because then the model will probably not be good. You want to track the metrics of your ML model, and then you want to also like track the production performance. So let's make sure that your P99 didn't go from 50 milliseconds to 2 seconds, if you want to promote a model. So those are the needs we have. We have an ML platform. I won't go into details because not the goal of the talk, but we're using Flight to train our models. So our whole stack is on Kubernetes. And yeah, Flight is running on Kubernetes, and that's what we use to train and orchestrate our workflows. Then we have MLflow that is here. You track your metrics. You track the different parameters. You can log the artifacts as well for your ML model. And then you can also compare experiments, being like, OK, I have multiple experiments, then I can compare them, have like graphs, have UI. So you're happy with it. Then you also have, and we also use MLflow model registry, which allows you to track which model is running where. So if you have a model running in staging, in production, then you also can track the different versions of your model. And you know where they're running. Then we have a lot of Python services to make life of our data scientists easier. And the last one is Selden Core. It's what we use to deploy models into production. And it takes a model, and basically it takes, you give it an S3 bucket or GCS. You also say which library you use. Did you use scikit-learn? Did you use XGBoost? Something. Then it's going to create a microservice for you. And then out of the box, you have automatic logging, everything. We use Kafka a lot, so then we log everything to Kafka. And then we push from Kafka to Snowflake. And then our data scientists can have dashboards and be like, OK, my model is doing pretty well. I also can compare it to the ground truth, and that they don't have to write code for that. So you have that automatically. Then you have A/B testing, canary deployment, a lot of things. So I have an ML platform, but in the title there was reliable. So we want an ML platform, but reliable. So at first, we deployed Flight. We deployed it without ArgoCD because we were not using Argo back then. Then we introduced ArgoCD for Flight. So it's been ArgoCD for the ML platform, we only use it for Flight. But what's really nice that then even our data scientists can then, they can ask for resources. They can add new things to Flight directly without us doing it. Then we have the whole ML platform, and then we have Argo workflows that we use with Gatling. And our Gatling is an open source load testing tool. And for the ML platform, we use Argo workflow with Gatling. And then I'll talk more about that later. But basically, every ML model that is deployed goes through a load testing, and we can make sure that it actually supports the load we want to. So ArgoCD and Flight. How we use them, so we use the cluster bootstrapping with ArgoCD. So yeah, I said before, but we deployed Flight at first without using ArgoCD. Yeah, was not really happy with it. Every day I would maybe cry in the corner because you apply something wrong, everything's broken. Now you don't have that anymore. So you're happy. Flight needs a lot of apps, a lot of different apps. And honestly, without ArgoCD, you spend most of your days trying to apply things and going to the right namespace and figuring out what's broken. So you don't need that. We have no Kubernetes experts in the ML platform. So ArgoCD has been really helpful on that one as well, just so that we can apply things in an easy way without becoming an expert and without asking also always the infra team, oh, can you apply that for us? Can you add that for us? So that's been really helpful. We don't apply anything manually, so we don't need permissions. We don't need specific permissions, to go to a specific namespace or to apply specific resources. Argo will do it for us. Also, it has rollbacks, because I break a lot of things. So when you apply something, then you also can roll back easily. And Flight supports plugins. So let's say you have Flight, you're happy, but then you want to use Spark on Kubernetes. So then you can. And then you create a PR. ArgoCD will pick it up, then deploys it to Flight, and then you can have a look as well yourself. You can look at the UI and be like, OK, my plugin is working now. I have now Spark running, or I have the MPI operator, or whatever plugin you want to add that they support. And yeah, data scientists can do that, so that I don't need to do it. Then I can go on a holiday more often, so that I'm really happy. So that's why we use ArgoCD and why we use it with Flight. Then we also have our whole, so you have Terraform modules, and we have our own one, which is a lot of wrappers around the Terraform modules. So that also what I like to not do is to write Terraform. So like that's what an infra team is doing and developer experience team is doing as well. They provide modules. So let's say you need to install Cilium on your cluster. Then you can just call the module, and then ArgoCD picks it up, and then installs it on the Fly cluster for a use case. But I don't have to write all the Terraform. That would be a lot of Terraform. I can just call the module. And that's what we have. That's what we have, ArgoCD and Flight. Yeah, maybe for people that don't know Flight, because it's very specific also to ML. So Flight is what we use now instead of Airflow for ML workflows. And why? It's because first, it's Kubernetes native, so pretty happy about that. It also supports automatic parallelization. So let's say you have different tasks running, and they don't need one others. You can just like have one that is, I don't know, like fetching some data, the other one that is doing, I don't know, whatever it's doing. But they don't need one each other, so then Flight will parallelize everything automatically. You don't have to think about that. You don't have to declare your dependency. You don't have to declare your task. Be like, oh yeah, please run this one before the other. They will figure everything themselves. You have reproducible pipelines, really important for ML. You don't want your pipelines that produce an amazing model to be like, oh, which one was it? Which version was it? So that's also why we use it. It supports caching, and caching is really good. Let's say your workflow takes 6 hours to finish, like 4 hours are going, and then at one point it crashes. You want to restart everything again. You don't want to like lose 6 hours. So then you have caching, Flight will pick it up everything, and then you only need to wait 2 hours instead of 6. Different SDKs. We only use Python in the ML platform team, but we have other teams that are using Scala, and they're actually going to use Flight soon. And yeah, Flight supports different SDKs as well. So if you want to use something else than Python, you can. And the best thing, in my opinion, dynamic workflows. So instead of saying, okay, like we are in 23 countries. Maybe we want to deploy a model, we want to train a model per country. You don't want to define in your code like, oh yeah, 4 are in 23, because then if you add a new country, then you need to change your code, and well, you don't really want to do that. So then with Flight, you can say like, please parallelize on this list, then it reads the list, and then it will create the task depending on the size of your list. Like 23 is an example. We are in more than 400 cities. Imagine if you have to change every time we go to a new city. That would be annoying. So yeah, it supports that out of the box, and that's been pretty handy. And I have a use case that I will talk about at the end, where I was even surprised we could do things, and our data scientists did it. But yeah, Flight workflows, what does it look like? I don't think you can see anything in the back because it's very dark. So I'm sorry. Yeah, you can't see anything. But you write normal Python, and then you just add decorators. So you're going to be like, okay, one decorator, which is going to be a workflow, and then another one, which is going to be a task, and then Flight will be like, okay, that's something I recognize. You can also run everything locally, like it's normal Python if you run it locally. And then if you run it in the cluster, then Flight will be like, oh yeah, I know that. Let me run workflows and tasks. And even better, because then I have another example, but you can't see anything in the back. But yeah, it's what we use for dynamic workflows. And that's what I was saying before. Like this one is doing cross-validations for all the ML models you have. And you are going to do cross-validation on all the ML models, but you don't know how many you have. And then Flight will figure that out itself, and then do cross-validation, and then return results. And basically that's it. Like you don't need to do anything else than calling the decorator dynamic. So that's nice. Sorry for the end, for the back. But yeah, then we use Argo workflows and Gatling. For people, I guess Gatling, I don't know if that's very famous actually, but it's an open source load testing solution, and what we use it for and what it allows us to, it's like to script our testing scenarios and automate our tests. It provides a visual report that is actually nice to look at, and you can really you have your app, and you should be able to understand fairly quickly what's happening, what's wrong with your app, how it behaves if you add more load and everything. I also have examples of the report. If you want to be really fancy, you have continuous load testing. We don't use it in the ML platform because our ML models, they don't need that. But for like your different apps, let's say you have an app that is really important for your company. Maybe you want to have continuous load testing. So every time you make a commit on GitHub, then you run a small load test just to make sure you don't add regressions, just to make sure you be like, okay, my P99 is still like 20 milliseconds. I'm happy. You can do that. Everything's running on the Argo workflows for us, so it's been really nice. And what's nice as well is that basically data scientists see Gatling and they don't see Argo workflows because they can be scared otherwise of like, like using Argo workflows and writing all the YAML and everything. So they see the end result, but they don't see how to do it. And then, yeah, we have templates. So you have the ML model. Then you just give the payload and the name of the ML model, and then we run load test for you. And then you see results, and you're happy or not. So that's what it looks like. It's better for the back, right? When it's actually white. So yeah, you have the template, then you give like number of requests per second maximum, how long you want the wrap-up to take, how long do you want your test to last for. Then you don't see it here, but you also provide the payload and the name of the model. Then you click submit. And if you have only one model, then Argo workflow will run one test. If you have 400, like we do sometimes, then it runs 400 tests in parallel. One of the example you have, that's like, yeah, one visual report, response time. You quickly see like, okay, it's good or it's bad. That one is just an example. So like, we don't deploy anything that has like less than 100 milliseconds. We usually are like less than 25 milliseconds. But yeah, we have a look at those. Then you have a summary. You can have a look quickly, like, yeah, my P99 is happy. Like, I have errors on this specific endpoint, whatever. And then what you can do is that you can also like increase the number of active users because you can be like, okay, my ML model works perfectly well if I have one user, but then what if you have 10, what if you have 20? And then you can like really see and really have a look at how many users you have, and then you can look at the response time distribution. Also, you can look at the percentiles over time, so you can really have a look and be like, yeah, most of the time I'm happy, most of the time we're happy, but sometimes we have spikes. So then, is it correlated to the amount of users you add, or like different things? Then you can like quickly maybe have an idea. Yeah, then you have number of requests per second with the number of active users, and then, sorry again for the back, you have assertions. So Gatling assertions is what we use to make sure that when you run load tests, you have some rules. Like we put some rules in place that is like, okay, we only make it pass if all our requests are less than 100 milliseconds, or we only make it pass if only 5% of the requests are failing. And then it will like report everything in GitHub, and then you'll have the GitHub statuses, and then be like, okay, you can merge only and only if you respect those assertions. So it allows you to like redeploy in a reliable way, without being like, okay, like without having to look at the reports every time you push something. You'd be like, yeah, everything is less than 100 milliseconds. I'm pretty happy. I can merge. All my tests are working. So yeah, you have those assertions. That's been really nice. So yeah, maybe why we went with that Argo workflows and Gatling is like, well, both like they can handle large-scale workloads. So like they can do way better than any of the ML model we produce usually. So like, you're really sure that yeah, your ML model is going to like work really well with the load test you have. I can press. My screen is gone. My screen is back. Then you have parallelism. So yeah, you can like leverage Argo workflows to manage multiple tests. Like we have one model. We train it on 460 cities, and then we load test it on 460 deployments. And we do that in parallel. So then we can make sure that, okay, everything working as expected for all the cities we have, so we can then deploy it and be happy and be more confident. Automated testing, it's what I said before as well with the assertions. So if you want, you can have everything in GitHub, then all the assertions, then Argo workflow. It's going to trigger everything, then report back to our CI/CD pipelines. So you can have also like you can have visual reports in GitHub. And yeah, you can make sure that everything works under high load conditions. So at least you're pretty sure that it's going to be reliable with that regard. Maybe you would fail for something else, but at least the load test, you're happy. And the use case I was talking about, so yeah, we predict traffic for each city we're in. We are in 463 cities, something, because traffic's different in each city. So that's the idea, is like, yeah, you really want to predict how long it's going to take for you to deliver the food, for us to deliver the food, depending on the city, because traffic's going to be very different in Tel Aviv than in Helsinki. So yeah, let's say you're a data scientist. You're like, okay, I need my GPUs. So, and then, like, we have GPUs running already, but then you might need some different GPUs. You might need one with more memory. You might need special ones. Well, you can do that. You create the PR. We accept it. Argo deploys everything. And then you can also like have a look and like look at the alerts, make sure that everything's deployed correctly. So that's the first step. Second step, you create a workflow in flight. You'll be like, yeah, that's my training workflow. Then you create a dynamic task that is based on cities. So you're going to be like, okay, for all the cities we have, please train a model. Then we'll have a toolkit that is an ML toolkit that every data scientist is using. So then in this toolkit, we have Python code that is like, yeah, please create a load test for that specific ML deployment so that data scientists don't have to do it themselves because it's always going to be the same code anyway. Then you load the test, load test per city in parallel. So yeah, 460 cities running in parallel. That's also why, the assertions are really important because you don't want to look at 460 reports. You're going to be like, okay, I have all my assertions. Everything looks green. I'm happy. I think we should be good. Then if you pass the assertions, you can promote the models and be like more confident that it's going to work. Or what you can also do is then you pass the assertions, but you can also make sure that you actually like not worse than the previous models. Because maybe your ML model is really good with the ML metrics, but if your P99 went from 20 milliseconds to 200, okay, maybe there's a right balance to find here. So that's our use case, and yeah, this use case is using everything we have. So ArgoCD, Flight, Argo Workflows, and Gatling. And our future work, so the first one, we want to add support for Triton inference. We start to use Triton more and more. The way Triton works is a bit different to every other library. So yeah, we want to add that, to add the support for our load testing tool. At one point, I hope, I have dreams, that we can load test 100% of the ML models that are going to production. So that means a lot of advocacy work. That means a lot of abstractions as well for data scientists, because they might be like, yeah, it's cool. What you're doing is cool, but I don't really want to spend time on it. So it's like, yeah, how do we make that easy, and how do we make it possible for them? Then if we can, I also would love to promote ML models only if the load test results are good and if the ML metrics are good. So that means comparing both of them. And then probably even more things that I can't think really about. I can't really think of, sorry. And that's going to be it. Thank you. And we're hiring, forgot to say.
Hi, thank you, Stephen, for our amazing talk. My question is around, I've got a twofold question. The first one is if when you parallelize those workflows in flight for 400 cities, if they spin up 400 pods, and if you are adding GPU support, how do you prevent for those type of jobs to spin up 400 GPUs? How do you ensure that they share the GPUs?
So the first one, for this one, then they're going to, with Kubernetes will pick up the nodes, and then it would be like, okay, I have this GPU that is there's that node, sorry, that has whatever GPU you have in, and then it will try to use that, but usually, yeah, usually we'll just spin up 400 GPUs. So that's, thankfully for this one, we don't need GPUs. Otherwise, we probably wouldn't be hiring.
Anyone else? Okay, thanks, Stephen.
Thank you.